Good afternoon, 5th and 6th grade. This is your science video. I'm going to give you your secret word first for, well, not first. I'll give it somewhere in the video for history. Today on science, I forgot to put it in the history video. That's why I'm saying that. We only have one work text page. And basically what we're going to be looking at is what a mixture is, and homogeneous mixtures and heterogeneous mixtures, and which ones would fit into those categories and why. And so we're going to be reading, though, in our reading, if I can find my book. Oh, here it is, right here. My syllabus. We are going to be reading pages 72 to 75. So go ahead and open up your book there, or pause and get it if you need to get it. Follow along as I read. This counts for your reading, by the way. This is not something that you have to do afterward as well. Hopefully you guys learned something a little bit, at least from that video that we did, or not the video, but the experiment we did with pennies on Friday. All right, so here we go. It's page 72. I'm talking about mixtures. And this will help to answer only that one page that you have today. All right, so it says mixtures. Sometimes different substances combine without going through chemical changes. A mixture consists of two or more substances that are physically combined. Unlike the molecules in a compound, the particles of each substance in a mixture keep their identity. Think of a snack mix. A snack mix is a mixture that can include pretzels, peanuts, and raisins. The pretzels, peanuts, and raisins did not change to other substances when they were added to the mixture. They each kept their own identities and properties. The amount of each substance in a mixture may vary. If your family likes a lot of raisins, you can add more raisins to the snack mix. You also could add other substances, such as crackers and candy pieces. Each substance in a mixture can be separated from the mixture. Since each substance keeps its properties, it may be identified and removed. You may like to pick all of the peanuts from the snack mix and eat them first. The peanuts look and taste different from the pretzels and the raisins. The matter in a mixture may sometimes undergo a physical change. Physical changes include changes of physical properties such as the state of matter, color, or texture. Strawberries and ice cream go through a physical change when they are blended to form a milkshake. Combining the strawberries and the ice cream does not form a new substance, though. You can still see the strawberries in the ice cream. In some mixtures, the individual substances are not spread evenly throughout the mixture, as in a snack mix. Another example of this kind of mixture is granite. If you look closely at a piece of granite, you will see that several kinds of minerals have mixed to form it. However, the minerals are not mixed evenly throughout the granite. Each piece of granite may have a different mixture of minerals in it. It's easy to identify the substances in some mixtures as being evenly mixed or not. You can easily see that vegetable soup is not evenly mixed. Likewise, if you look at the sand on a beach, you can see a variety of rocks and shells in it. No two handfuls of sand have exactly the same substances in them. Some mixtures separate if they sit for a while. Orange juice, some liquid medicines, and paints are mixtures that separate. These mixtures may have labels that say shake well before using. Shaking these mixtures combines the substances again. The shaving cream that many men use each morning is also a type of mixture that is not evenly mixed. I can tell what kind that is right there on that bottle. In fact, that'll be your science word for today. It's not shaving cream, but it is Barbasol. It's Barbasol. Barbasol. And so shaving cream mixes a gas with a liquid to form a mixture called foam. An aerosol is also a mixture of liquid and a gas. In some aerosols, you may even be able to see the droplets of liquid. Some hairsprays come as aerosols. And so you see a picture of an aerosol being sprayed at the bottom. All right, so let's go on to the next page, 74. All right, so separating substances in mixtures. Substances in mixtures are not held together chemically. They can be separated using their physical properties. Some mixtures are easy to separate based on how the parts look. You could look at a snack mix, kind of like when I'm digging for a Reese's in the bottom of the candy jar, where there's one Reese's and it's at the bottom, and I can't get to it easily. But it's there, and you can just pick it out because it is a different type of mixture. You could look at a snack mix and easily remove each ingredient. You could take out all the pretzels and put them in one pile. Another pile could then be made of all the peanuts, and so on for each food item. Suppose you had a jar full of coins. You can separate them by how they look, but if you had a coin sorter, you can separate the coins more quickly. Coin sorter separates the coins based on each coin's size. Sometimes you can separate dry items. By the way, it's not just size. Sometimes they separate them by weight as well. Sometimes you can separate dry items by gently shaking them. The smaller items fill in the gaps at the bottom of the container. The larger items are pushed to the top. The items often settle into layers because of their sizes. When each of the liquids in a mixture has a different density, the mixture may separate into layers. The order of the layers depends on how dense each liquid is. The densest liquid will be at the bottom. The least dense liquid will be at the top. Oil and vinegar salad dressing separates in this way. Oil is not as dense as vinegar and goes to the top. Unless you shake the mixture, the two liquids will stay in different layers. If you are careful, you can separate the mixture by pouring off most of the oil. And that's one way that you can do that. And then page 75, we'll read the bottom part first, then we'll go back to the top section there on science and history. Solids may also separate based on density. Perhaps you have seen how sediment in a stream forms. The densest substances settle out first, then other substances settle out according to how dense it is. Not all mixtures separate easily, though. Suppose you had a mixture of salt and sand. The pieces of salt and the pieces of sand would be nearly impossible to separate from each other. However, you could use some of the physical properties of salt and sand to make them easier to separate. One of the substances dissolves in water and one does not. If you added water to the mixture of salt and sand, the salt would dissolve in the water. The sand would settle to the bottom of the water. After pouring out the salt water, the sand would be separated through its physical properties. However, the mixture would not yet be completely separated. The salt would still be combined with the water. A way to separate the salt and water would be to boil the salt water. Boiling causes the water to change from a liquid to a gas. The salt would remain in the container. I did that when I was in 8th or 9th grade. I remember doing that. And we had a little tube, and the water that was being boiled off, it had a little stopper in the beaker that was being heated with a Bunsen burner, and it would go through the tube, and it would get all the water would drip into the other container, and then at the same time, then we would then the salt that was would stay at the bottom of that container, and all that salt would come to you. They do the same thing with desalination, or a similar thing with desalination of salt water in the oceans or seas like that have salt in them, for the purpose of using the water as drinking water. Israel does this. That's one of the things that they really need to do. So back at the top here for the science and history, one method of separating mixtures has had a great impact on the history of the United States. This method, called gold panning, was once used to separate gold from the mixture it was in. In 1848, James Marshall found gold in a river in California while building a sawmill for John Sutter. This began the Great California Gold Rush. Many men rushed to try their hand at panning for gold. To pan for gold, a man would put a small amount of dirt, gravel, and water from a stream into a shallow pan. He would then slowly shake the pan. The movement caused the materials to separate based on how dense each material was. Gold has a high density and would sink to the bottom. Much of the other material could be carefully poured off with the water. Gold and some other dense rocks would remain at the bottom of the pan. The shiny gold flakes and nuggets would then be picked out of the pan. So you know how panning was done. All right, so that is your reading for today. And the 6 things that you have to identify based on whether they are physical or chemical change, that is for you to do. And hopefully you'll have an easy time with that. I don't think you'll have too much difficulty. All right, that's it. Have a wonderful day, and we'll see you tomorrow. Bye.